Hey guys, so I've already made this video once, but I don't have any, my camera stopped working. I don't have any whiteout, so I'm just covering up part of this and I'll reveal it as we go, I guess. So I don't want to rewrite the whole paper for this. Anyways, so this is part A of our 5.7 lesson on polynomial transformations. And we're just going to kind of jump into some of this. You guys should have got in your notes the this table in here from your textbook, and it just runs through how you do the transformations, and it's pretty much the same thing as what we had for quadratics. So if you see translations, that's where you add or subtract numbers. So vertical translation, it would be where they're adding or subtracting a value just to the x, and so it's inside the parentheses with the x, like inside where the exponent is being raised to. So, but if it's a vertical translation, you're going to add the number on the end. Reflections multiplied by a negative, so you can either reflect across the x or the y-axis. If you multiply by your negative on the inside of the x, or inside of the of where the exponent is, then that's going to reflect you over the y-axis. And if you multiply by a negative on the outside of the equation, then that's going to flip you over the x-axis. You have your stretching and shrinking, and horizontal stretch and shrink always works opposite of what you think it is. Horizontal stuff happens inside the parentheses, and but when we say that we want to shrink by a factor of 1/2, that ends up multiplying actually by 2 on the inside, whereas if I was going to stretch by a factor of 2, that's going to multiply by the number 1/2. So you're going to, the factor is the reciprocal. You're going to flip it. In vertical stretch and shrink, you don't have to flip anything. You just multiply straight away like what that number is. So if they say that they want to stretch by a factor of 8, you're going to multiply by 8. If you want to shrink by a factor of 1/4, you multiply by 1/4. Notice that this is not inside the parentheses, so these numbers are not being raised to the power, whereas on the horizontal stretch or shrink, they are being raised to that power. So we're just going to jump into it. I'm going to go into problem number 1, where this is on page 258. They say to describe the transformation f of x equals x to the 4th, represented by g equals x minus 3 to the 4th minus 1. Then they want me to graph each function. So in this one right here, you can see I've got my f and my g, and we're going to describe this first. So I see that my f of x function is pretty simple. There's nothing much going on. But the g of x function has some numbers that are being subtracted. So I'm seeing one number being subtracted on the inside of the parentheses and one being subtracted on the outside. These are translations, but and when it's on the inside of the parentheses, that's your horizontal. And when it's on the outside of the parentheses, that's the vertical. So on the inside, I see that this is saying x minus 3. Horizontal stuff always works backwards from what we think. So that means it's going to actually move to the right 3. And then I see on the outside, this is going to, it says minus 1. And so that means it'll move down 1. So we have this thing should be translating to the right 3 and down 1. So here's my description. Like I said, I wrote this already because I tried to make this video and my video froze. But it says G has been translated, right 3 and down 1. All right, the next thing is we're supposed to graph these. So I go through and I make my XY table. So I started making one for f of x already. And so just make your XY table, and I went ahead and put my important values that I always like to test. So I always like to test -2, -1, 0, 1, and 2. And then we kind of go from there. So what I did is I plugged these in. You plug these into my f of x function, which means I'm just going to raise them to the 4th power. So if I raise -2 to the 4th power, that'll be 16. If I raise -1 to the 4th power, that's a positive 1. If I raise 0 to the 4th power, that is 0. If I raise 1 to the 4th power, that is 1. If I raise 2 to the 4th power, that is 16. So now we are kind of caught up. All right, so if I was going to graph this, I went ahead and made my graph to begin with, just to kind of lay it out and saves us some time. But I did make this go up 16 little tick marks. So I'm going to go ahead and plot these points. -2, +16. It's going to go about there. Then we have -1, +1. So there. We have 0, 0. We have 1, 1. And then we have 2, 16 again. Okay. So you can see with this graph, it's going to be a pretty sharp, a pretty steep curve here. All right, something like that. Yeah, didn't do a good job. There's a ridge in my table right there, so my pen got caught in it. But there you go. All right, so there's our f of x function. Awesome. Now, I also need to graph my g of x. So I'm going to go ahead and make an xy table for that. Now, you can either plug in the same numbers. If you plug in the same numbers, it may not work so well because this thing has been translated to the right 3 places and down 1. So here's a trick that I like to do. If I know that this stuff has been moved to the right 3 places, that's going to affect the x values that I want to plug in. So I'm going to actually start plugging in my x values 3 places to the right of where these ones were, and that'll kind of center my graph a little bit better because this is centered nice and pretty. But if I use these same points, it's not going to be the center of my graph, and honestly the numbers will be too big for me to be able to fit them on the graph. So we're going to try to be smart about this, and I want to pick some numbers that will graph better. And so you think of this vertex, if it's been translated to the right 3 and down 1, my new vertex should be there. I should have a point at 1, 2, 3, -1, and that should be where my new kind of like vertex is, okay? And then I can center this around this. So this would be 2 and 1, 3, 4 and 5. And this will just give me a better picture of my graph, okay? So if I plot these points, or if I plug things in here, I can plug in a 1. 1 minus 3 is a -2. -2 to the 4th power is 16. Minus 1 is 15. Okay? If I plugged in 2, 2 minus 3 is a -1. -1 to the 4th power is a +1. Minus 1 is 0. If you plug in 4, 4 minus 3 is 1. 1 to the 4th power is 1. Minus 1 is 0. This is bouncing back. I will actually get my 15 back when I plug in the 5. So we get a nice and symmetrical graph on this one. I'll have a point at 115. So this will be at 115, about there. I'll have a graph at 2, 0. So here. I'll have a graph at 4, 0 there, and then I'd have one at 5, 15 again. I just need to be very sharp about this curve. So this is my g of x. Okay? Got them both graphed. Awesome. All right, we're going to do one more in this video. So I have, I think my instructions on this one are the same, but I'm going to run back to it just to be sure. This is on the next page, so 259. They say to describe the transformation f of x equals x cubed, represented by g of x equals 4 times x plus 2, all cubed. Then graph each function. So same directions, we're going to describe it and then graph them. So same type of deal with the plus. I see that this has been translated on the inside, so I know that it's going to be moving to the left too. I'm also seeing that this thing is being vertically stretched by 4. When I see that number being multiplied in the front, that is a vertical stretch. So we're going to say that g has then vertically stretched by 4 and translated horizontally 2 units to the left. Okay, so we're going to graph each one. I'm going to go ahead and graph our f of x function, which is the parent cubic function, and I'm going to test those same numbers I really like. So we're going to start off with -2, -1, 0, 1, and 2. And if you need to plug in more, you always can. This is always just a starting place, so you can't guarantee every graph will be good from this. You always want to start here, and then you can always plot more points if you need them. So if I plug in a -2, -2 cubed is -8. If I plug in a -1, -1 cubed is -1. 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. So this gives me a list of points to graph my f of x. Let's see, how big did I make this? 1, 2, 3, 4, 5, 6, 7, 8. I made this a little bigger than I needed to. But when I plug these in, this will be a -2, -8. So 2, 4, 6, 8. Here. We have -1, -1. 0, 1, 1, 1, and then 2, 4, 6, 8 this way. So this is my f of x right there. Okay. Then I need my g of x. So let's go ahead and make an xy table. Now again, I know this thing moved horizontally to the left too. So I know my new kind of like middle turning point should be about there. It didn't move up or down at all, but I should have a point there that would be kind of in the middle of everything. So this is at -2, 0. I should have a point there, okay? Now things that are to the left of that would be -3 or -4. To the right of that would be a -1 and 0. So we can plug these things in and see what we get out. If you plug in a -4, -4 plus 2 is -2. -2 cubed is -8. And the -8 times 4 is a -32. Hold on, pause, let me double check. Plug in that. -4 plus 2 is -2. -2 cubed is -8. -8 times 4, yes, -32. Sorry, I just want to make sure. It's early in the morning, so my brain's not always here. All right, if I plugged in a -3, -3 plus 2 is -1. -1 cubed is -1. -1 times 4 is a -4. Okay. If I plug in the next one, I should have got 0. If I plug in a -1, -1 plus 2 is 1. 1 cubed is 1 times 4 is 4. And this thing should bounce back. So I don't have my graph tall enough for 32, but it's at least, we can get an idea. This thing is going to be stretched, so it should be a lot thinner than the one that we had previously. So I can't really graph 4, -32, but I can graph -3, -4. This would be 2, let's see, 1, 2, 3, 4. I should have a point here, -3, -4. And I should have one at -1, +4. So you can see here, this should still have the same kind of shape to it, but it's not, it's a lot steeper. Oops, sorry, I'm on that ridge in the table again. Okay, and this is your g of x. So kind of tedious. This is the whole plotting points thing. I should see where you plotted points and see your xy tables and things like that on your graph, on your paper. So please make sure that you show all of your work, that you describe your graphs fully, that you plot your points so that you can get full credit, because we won't be awarding full credit for just drawing what the kind of shape is. You need to have points, everything drawn nicely. Okay? Good luck, and let me know if you've got questions. Send me a message if you need to, okay?